Okay, so this video is going to be about finding the area and the perimeter of irregular shapes. Some vocabulary that we want to look out for is what an irregular shape is, measurement, dimension, and visualization. Please pause the video now and copy down the formula sheet. We're going to need it for later. As mentioned in the title, the overall goal of this video is to be able to successfully find the area and the perimeter of irregular shapes. So let's take a look at the figure below. Let's think of this as a garden, except instead of having feet, let's have inches. So as mentioned earlier, we want to find the perimeter and the area of this garden. How can we do this? We're going to start with area. That is, we're going to try to find the area of this irregular shape, or the area of this supposed garden. How can we do this? The shape, or this garden, can be broken down into two or more regular shapes, such as triangles or circles. We're doing this because we know how to find the area of such regular shapes. As you can see in the picture, I placed some lines, so we have a semicircle, a rectangle, and one last weird shape. For this last weird shape, let's cut it up to be a right triangle and another rectangle, like so. Again, the reason we are breaking down this irregular shape into a bunch of regular shapes is because we easily know how to calculate the area of these regular shapes, as opposed to this irregular shape. So let's start with the bottom left rectangle in this regular shape, labeled in blue. Looking back at our formula sheet, we know the formula for finding the area of a rectangle is length times width. Now the length is pretty easily shown in this diagram as 3 inches. The width is going to be a little more difficult to get. You see, the width of the entire irregular shape is 28. But we don't want the entire width, we only want the width of the rectangle. So therefore we're going to subtract 20, so we only have the width of the rectangle. We'll do some quick simplification to where we can arrive at our final answer, that A equals 24. So let's continue. Let's try to find the area of this right triangle, shown in green. If you recall back to your formula sheet, the area of a right triangle can be found by taking 1/2 times the base times the height of the triangle. Our base can be found by taking the length of this rectangle, which we knew was 8, and subtracting 4, since the 4 has nothing to do with the right triangle. Now that we have the base of our triangle, we need to calculate the height. We can calculate the height by recognizing that the entire irregular shape, that the highest height that our irregular shape has is 8 inches. Now because a triangle is not obviously the highest height of our irregular shape, we need to subtract the 2 and the 3 inches. When we simplify this down, we get that the area of the right triangle is 6. The next piece or slice of our irregular shape that we're going to calculate the area of is going to be the semicircle. Recall from your formula sheet that the area of a circle can be found by taking pi times the radius squared. We also want to remember that the diameter of a circle is 2 times the radius. So with the diameter of 8 in the semicircle, we know that radius is going to be 4. Now even though we have the formula for finding the area of a circle, we're only dealing with a semicircle, or half of a circle. So therefore we want to multiply our formula by 1/2 to get that the area of this half circle is going to be 1/2 pi r squared. We do some substitution and some quick simplification to get that the area is approximately, that's what that squiggle line means, approximately 25.14. So we are on the home stretch of finding the area of our irregular shape. Lastly, let's find the area of this final rectangle. We know that the length is going to be the upper part of our regular shape, or the 20 inches, minus 4, because our semicircle has a radius of 4. And we know that the width is going to be 8, because 8 was the diameter of our semicircle. This simplifies down to that the area of this rectangle is 128. Now here's the cool thing. Because we cut up this irregular shape, if we add each individual area of our regular shapes, we then get the area of the irregular shape. When we do this, we get the approximate area of the irregular shape, approximately because we used pi when calculating the area of our semicircle. We get that the area equals 183.14 square inches. The units is going to be square inches because we're dealing with area, and our original unit were inches. Now that we found the area of this irregular shape, we want to find the perimeter. This can be easily done because, for the most part, every single side of this shape, or what we call a garden, was already shown in the diagram. However, there are two missing side lengths that we need to know. The first has to do with that right triangle that we cut out before, and the second has to do with the circumference of the semicircle. So again, let's start out by recreating that right triangle, and let's try to figure out what we used for base and height. If we recall, for our height we used 3, as well as for the base we used 4 inches. Going back to our formula sheet, we can use the Pythagorean theorem to actually find this missing side length of this right triangle. Note, this only works because the triangle is a right triangle. We do some simplification, so we get that the missing side length is 5 inches. Now for the last side of this irregular shape, or the circumference of this semicircle. The circumference of a circle can be denoted as 2 times pi times r. However, we're only dealing with half of a circle, so therefore it's 1/2 times 2 times pi times r. We know that the radius, because we used it during our area formula, we know that the radius of the semicircle is 4, so we can substitute this in. We can do some quick simplification to get that the circumference is approximately 12.57 inches. Similar to what we did with the area, we're going to take the sum of every single side of this irregular shape. When we do this, we get that the perimeter of this irregular shape is going to be approximately 74.57 inches. We have successfully found the area and the perimeter of this irregular shape. If this video helped, please leave a like. For any questions, please comment below. And for future videos, please subscribe. Thank you.